VLSos here. This is a video lesson, slope-intercept form. Slope-intercept form is a form of equation for lines. We're going to start with an example before we talk about what we mean by slope and intercept. We're going to start with an equation, y is equal to 2x minus 3. This is an equation. It's a linear equation because its graph is a line. We're going to graph this by making a t-table, choosing values of x, and using the equation to find the value of y. This is a method that always works. It's reliable, but it often takes a while to use this method to graph. I'm going to choose some values of x. I'm going to choose 0, 2, and 4. For each value of x, I'm going to use the equation to find the corresponding y. With my choice of 0 for x, y will be equal to 2 times 0, which is 0, and then minus 3 makes y negative 3. This becomes a coordinate in the table 0, negative 3 that I can plot on my axes. I'm going to complete the table first. I'm going to choose 2 for x. Y will be equal to 2 times 2, which is 4, minus 3, which is 1. So when x equals 2, y equals 1. Choosing x to be 4 and substituting it in, y is equal to 2 times 4, which is 8, and then minus 3 makes y is equal to 5. I've got 3 coordinates to plot. I'm going to plot the second one first. When x is equal to 2, y is equal to 1. On the x-axis, I'll make a tick mark at 2, and on the y-axis, 1. That coordinate 2, 1 is right there. Graphing the first point at 0, negative 3. So on the x-axis, I don't go anywhere. I'm at 0, and negative 3y is down here. I'll make a tick mark at negative 3 and plot that point. The point 4, 5 is x is equal to 4, and at the same time y is equal to 5, plots right there. I can connect these points to represent the entire equation. The graph of this equation is a line. Graphing this way always works. But with the slope-intercept form, we might be able to speed things up in our graphing and understand some things about our line. We're going to write what we call the general slope-intercept form of a line. And this general equation is y is equal to m times x plus b. This is an equation of a line, but it's in general terms because we don't have any specific numbers. We still have the two variables x and y, but we've also used letters to represent these pieces of a linear equation that are important. And m is being used to represent the slope of the line. If we were to graph a line that had this form, then the number that multiplied x, the x variable in the equation, would also be the slope of that line, the measure of the line's incline. This value that we add to the term that has x in it is the y-intercept. The word intercept is kind of like another word for intersect or intersection. So the y-intercept is literally the place on the y-axis where the graph of the line will cross or intersect or intercept the y-axis. If we take a look at our general form and our example, we can see that our example was an equation for a line in slope-intercept form. In this case, in our example, the number that multiplied x is 2. In the general form, the number that multiplies x, we represent it with the letter m, is the slope. So the slope of the line that we graphed is 2. And we can show that with the concept of the slope. You could take these 2 points and remember from the previous lesson that the slope is going to be a fraction that is made from the change, the horizontal change and the vertical change. The horizontal change is how much we have to go over to go from one point on the line to another horizontally. And the vertical change is how much we have to go up or down vertically to go from one point to another. I can represent the horizontal change and the vertical change with these lines. And for this line, this horizontal change, or what we call the run for short, is equal to 2. And the vertical change, which we call the rise, is equal to, for this line, 4. And with these 2 numbers, rise and run, we can make the slope. The slope, the measure of the line's incline, is rise over run in general. And for this line, a rise of 4 divided by a run of 2. And we can simplify that, 4 divided by 2, as 2. Note that the position of the number that multiplies x in this equation that represents the slope is 2. The number multiplying x is 2. The slope has been calculated to be 2. So we've confirmed that this number, like the general equation, is the slope. We're told in the general form that the number that we add or subtract to the term that has x in it is the y-intercept. And we have a negative 3, or 3 being subtracted from the 2x term. Negative 3 is this equation, or this line's intercept. And the intercept is where the line crosses the y-axis. Does this line cross the y-axis at negative 3? We can see down here that it does. We have a point at 0, negative 3. I'm going to point to that and note that on this graph, we have a y-intercept at y equals negative 3. In the equation, we have a 3 being subtracted from the term that has x. We know in general that we call that, we use the letter b to represent that value, and we call it the y-intercept. And it corresponds in this equation that we have a y-intercept at negative 3. When an equation for a line is in slope-intercept form, we can very quickly get an understanding of these 2 important concepts without needing to graph the line or make a t-table. If we're given an equation like this, and we observe it's in slope-intercept form, if it is y is equal to a number times x plus or minus another number, then the number multiplying x is the slope, in this case negative 3, and the number that we're adding or subtracting is the y-intercept, abbreviated y-int if we want, and in this case is a positive 4.